Hi, my name is Jason Olson, and this video is going to help us to understand the phase relationship between voltage and current with a capacitive circuit. We know the properties of a capacitor and that it is two metal plates separated by a dielectric. It's important to remember that dielectric is an insulative material and there's never any current that is passing through that insulative material. If there is, there's a problem with our capacitor and it needs to be replaced. So when we have our capacitor connected into our circuit and we connect it to an AC source, that AC source is continually changing. North America, we're going to use a frequency of 60 hertz. So with that continual change, we're going to have a continual charge and discharge of that capacitor. So at the point of energization on my electrical circuit, theoretically there is no opposition between my source and that capacitor. So because there's no opposition between those points, there's nothing opposing current from reaching its maximum value instantaneously. So what we have is that current rising to its maximum value instantaneously, which is represented here. We see at the first moment in time, current is at a maximum voltage before that capacitor is charged. This capacitor will charge to whatever voltage the source is. So if we have a 120 volt AC source, this capacitor will charge to whatever voltage is present at that source. If this is an RMS voltage, the value that that capacitor will charge to is 170 volts peak, because that voltage is present at its peak point in time. So this current, when it reaches its maximum value, and it's taking a period of time for that capacitor to charge, our waveforms represent those two periods of time. And that when current is at a maximum, this is happening before voltage has reached its peak value. After a period of time has gone by and voltage is at its peak value, this is where current will be at its minimum. So on our phasor diagram, we can represent that same phase displacement, and we can actually show what that angle is. On my Cartesian plane in my phasor diagram, if I use voltage as my reference, I can represent that current is a leading voltage by a period of time. So our electrical cycle is counterclockwise. So when we look at the phase relationship, we see that current is leading voltage by a specific time. So if this is our current value, this is our phasor diagram representing voltage, we see that current is leading voltage by 90 degrees. When we relate that back to our waveform, we see that that is true. When current is at its peak value, voltage is at 0. Peak value happens at 90 degrees. When voltage is at its peak value, current is at a minimum. Current is at 0. We look at how that is affected by Ohm's law. And the most important thing is to remember that Ohm's law is still true in this case. I equals E over R. That's the formula that helps us to represent Ohm's law, is that voltage is directly proportional to current and inversely proportional to whatever is opposition. In this case, we shouldn't use R because it's not about the resistance. It is about the capacitive reactance, or the XC of that circuit. So we look at this point in time, and the confusing part can be, well, if I have an increase in voltage, Ohm's law said I should have an increase in current. Well, we have to remember that this is representing time. This horizontal component represents time. When I have an increase in voltage, I should have an increase in current. But it happened before voltage rose because of the properties of that capacitor. When I have a decrease in current, Ohm's law says we should have a decrease in voltage. We have to remember it takes a period of time for that to take place. I have a decrease in current, then I have a decrease in voltage. So with that statement, we look at the properties of that capacitor, and we could say current leads voltage, and we know the time. It is by 90 degrees. The other statement is if we could say current leads voltage by 90 degrees, we could also make the statement that voltage lags current by 90 degrees. Those are equal statements. I hope this helps. We'll see you next time.